So let's say you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
So this is the one I had so much trouble the other night with, the transitional form. If you compare that to Mrs. Plez, what is the major differences?
And I'll drop the opacity down a bit so we can kind of get both of them at the same time.
Yeah, show me again, Dapper.
So we got Mrs. Plez. We got
yeah, absolutely a much flatter face. This individual is much more orthognathic than Mrs. Plez is, and we see, go back to Plez again. And back once more. It looks like we're seeing almost a vaulting, the beginning of the vaulting of the forehead, however slight that may be. Basically, we're seeing an extension forward of the muzzle, and this part of the skull here is going downward, and the face is flattening. So I would argue that the main difference between the two actually has very little to do with the cranial capacity and very much to do with the differences in the face shape, which doesn't seem to be very people don't tend to think of that when they're thinking of the significant differences between a human and a chimpanzee, but it actually is very much at play how prognathic the muzzle is and the face in general, because obviously there's orthognathism and prognathism with the face from the rest of the crania, and then there's also orthognathism and prognathism with the muzzle itself, which is the actual jaws.
now. Maybe I'm way off here, but it seems like right now in this skull we're starting to get into that area where the crossover between, say, Australopithecus and Homo erectus, Homo is starting to get a little bit blurry. Am I wrong there?
I would say knowing the cranial capacity volume would be key here, because generally speaking, the transitionals, quote unquote, are going to occupy that 600 to 900 range.
Right.
Now,
but let's say all we have is these pictures in isolation. Are we?
I would say, yes, only because when we consider our hominins all lined up with one another, the brain case size is one of the last things to change, quote unquote. Like, what we tend to see is the retained neoteny in the face before it is possible for the brain case to grow, at least to the extent that we see in late genus Homo. So I would say, like, if you showed this to me and you were like, who is this? I would say it's possible that we're looking at a basal member of Homo erectus, but I would also say it could be as early as Australopithecus sediba. If I was a betting woman, I would say maybe Homo rudolfensis.
Okay.
Okay.
So Kane, the reason I asked that is because you said you had problems with this skull, and to me it looks like it's right in the gap that not necessarily right in the gap, but it's bridging that gap that you have seen in your data. It looks like this is the skull that is sort of breaking that mold, where you're seeing distinct clusterings, and to me this looks like the kind of thing that I would expect to see crossing over from one set of those clusters to the other. But I mean, I could also be wrong because I don't have the measurements on this particular specimen. Although, handily, you can probably find them if you get access to the paper that that does that. And I'm not saying that you should pirate papers on Sci-Hub or anything. You should definitely not do that, obviously, because it would certainly be a tragedy to the world if high-priced scientific journals had to stop charging like $45 an issue because it was too easy for people to get free copies of their papers on a website that some Russian person made.
Okay. So I have a question.
Yeah.
If this was found at the very beginning of your, say, like, just after Ardipithecus and Australopithecus, would you have any problem in saying that this is just an odd Australopithecus?
If I found it as an individual,
Yeah,
like,
I'm
if
not
you-
sure. Are
Yeah.
you saying like where it was found in like terms of the geology?
Yes.
if I found this and see the problem is my defining characteristics as an individual would be, I would say this is definitively a biped based off of where the foramen magnum is located. I would measure the cranial capacity and I would take the angle of the prognathism and compare it to what else we have. Now, geologically speaking, if I found this at the very beginning, I would be intrigued. I would be like, okay, well, where is it found? But that being said, we know Kenyanthropus platyops has a very orthognathic face and still a very small brain case. So it would. I realize this is it feels kind of around the bush, but I would essentially pause and take more information. Like, I wouldn't feel comfortable saying either way at this point if I just had that skull where it fit in, even if it was indeed very early.
Okay.
So the very next slide should be from the same place, the Demansi
Mm-hmm.
formation, I believe it.
I think it's Demonisi.
Okay, Demonisi.
It's okay.
You're gonna
I
get-
said it wrong too.
I'm gonna get that through my thick skull someday.
No, me too. I know.
But
Okay.
so this is of the same location.
Right. Homo georgicus, if the processes in human evolution is anything to go off of.
So can you lower the opacity of this one?
Absolutely. If I remember to click on the correct layer.
So the paper that I'm not sure it was a paper. It might have just been a news article. But either way, it said that the different individuals from the Demonisi formation all fell into the same range of characteristics that you could expect in if you just grabbed randos off the street. You could find
Right.
the same variability.
I hope that was a paper because I want there to be a paper with the phrase "randos off the street."
Ugh,
I want that.
no,
I want that to be in the literature. Come on. So okay. So basically, you're saying that according to the source that you read, and I mean, hey, you can't remember exactly what it was. That's fair. That these two skulls are in the same sort of morphological range as you would get, say, in modern Homo sapiens.
Right.
So there are a couple of interesting things about that. The first is that modern humans are relatively restricted in our overall variability when compared to some of the other primates. Not all of them, keep in mind, but certainly with regard to some, particularly when we consider that Homo erectus and its variants slash subspecies or slash sister species, depending on how we're categorizing it, they're known for being particularly variable just because we see this rapid, quick expansion right out of Africa. Because if memory serves, the Demonisi specimens are found in Georgia, not Georgia the
Correct.
state, Georgia the country, which is much further north than previously found hominins were. So what we would naturally see if evolution is operating as it should is a very quick adaptation to local conditions. What those local conditions and how they were acting is beyond me. That's obviously not what I know. But one of the reasons why Homo erectus is considered to be so highly variable, and again, when I say Homo erectus, I'm meaning it in the sense of potentially encompassing Homo georgicus and Homo ergaster, which the Demonisi specimens would be Homo georgicus, quote unquote. So I would tentatively say it wouldn't be outside of the realm of possibility that we're seeing an environmental response here. Again, I don't know with regard to without having the genetics, the nature of Homo erectus and the species that it potentially encompasses is somewhat of a mystery and still in a forgive me, but an evolving situation. But what we do know is that Homo georgicus, if indeed it's its own species, occupies a range of brain case from 500 to, 690, something like that. No, 775.
Wow.
550 to 775.
That's a big range.
Which is a huge range. But again, we have to consider that sexual dimorphism, and again, sexual dimorphism is what I study for my master's, in primates is ridiculously capable of fluctuating. For instance, we have a species of colobin, which are known for having highly dimorphic canines, Colobus goriza, and Colobus goriza has females with gigantic honking canines and itty-bitty canines, depending on where they are found in their environmental climate. So basically what we're witnessing is a change in action that's rooted in the environment, because as they come down from the trees, it's more advantageous for females to have bigger canines so that predators won't mess with them because they think that they're males and they're more capable of wounding.
Or I was just going to say, or they could just actually mess up a predator. It's also an option.
No. Yeah, exactly. It doesn't really matter the perception of the predator and what that actually is. Versus, it's all about signaling.
Yeah,
right?
You're scarier now because you got fangs.
Right. So basically, what I'm saying here is sexual dimorphism is a very plastic trait in primates. So it wouldn't surprise me if the Dymenici specimens are highly dimorphic, because just as monomorphism can arise quickly, dimorphism can as well. Now, looking at extant species is typically the best way to gauge what past species are capable of. And when I say best, I mean it's our most empirical, because we can look at something that exists now and say, well, we know it exists now, therefore it is possible to have occurred in the past. So while Homo erectus isn't typically very sexually dimorphic, again, as I said earlier, we can never put sexual dimorphism, even in its more extreme forms, out of the picture. Because if memory serves, the Dymenici specimens are indeed all adults. They all have their wisdom teeth. So we're definitely looking at a range of adults. We can't say that one is a juvenile, the 500 brain case or 550 brain case is a juvenile, and the 775 is an adult, which means the realm of possibility here is that we're looking at males and females. Keep in mind, too, that males and females, even in species that aren't very sexually dimorphic, can vary wildly. If you look at a Norwegian woman and an Asian man, for instance, you would think that the species, if you found them in a vacuum, was exhibiting reverse dimorphism, where the females are, 1.5 times the size of the males. But if you did that in the opposite direction and you took, for instance, a Maasai man, sorry, that's a dog, a Maasai man and an Asian woman, you might think the opposite. You might think this species, holy cow, is exhibiting dimorphism the level of Mandrillus sphinx. Hold on. Hey, guys. Anyways, basically what I'm saying is that particularly when you've got a population of individuals, you can judge with fair certainty whether or not you're looking at sexual dimorphism or a single population. And at least according to what Processes in Human Evolution says, which is typically, since it's a 2017 book that's still in circulation, is the consensus. What we're looking at is sexual dimorphism. Now, the unusual part about that is that we're looking at sexual dimorphism to a degree that isn't typically seen in the species. So that's the part that's weird. Not necessarily that we're looking at an Australopithecine co-inhabiting Georgia alongside a member of Homo erectus, which also isn't necessarily outside of the realm of possibility. It's just not nearly as parsimonious as what we know about given what we know about primates.
Right. I'd like to compare these two back to the Ples before we move on. Yeah, you were going there.
Yeah, and we got this one. And Ples?
They're obviously more robust than Ples, right?
Not just more robust, but they are more orthognathic. So a more forward and flat face. I'm pulling up Mrs. Ples's brain case volume really fast too, so we can compare that.
Want me to do the next one?
Sure.
So really fast, interestingly enough, and this is the key bit with that breadth of the skull. So Mrs. Ples has a cranial capacity of 485 cc's, which is still under the smallest cranial capacity of the Dymenici Homo erectus or Homo georgicus specimens. So while in overall shape, what we do see, if you'll go back to Mrs. Ples Dapper for just a moment, what we do see is similarities in overall shape. This brain case it's not nearly as evident because we're looking at it in 2D, but the brain case still is outside of the range of the Dmanisi specimens, which is important to keep in mind. Yeah, and Naledi is weird too because Naledi is known for being relatively basal in its upper body, and it has a relatively small cranial capacity for a member of Homo.
So, for Naledi, would you say it's more similar to Mrs. Ples than to Erectus?
Yes, I would say that the gross morphologic features of Homo naledi with regard to the crania share a lot in common with the Australopithecines and a lot in common with genus Homo. I would say the main reason probably why Naledi is considered genus Homo rather than an Australopithecine is because Homo naledi, while its brain case is small for genus Homo, is large for an Australopithecine. So
is this one of those things that would probably be smack in that gap?
Yeah, I would. So the interesting thing about Homo naledi is its range. So I just pulled up the range, and the range is 450 to 600 cc's. So the range for males and females for an Australopithecine would be 400 to 500. So 450 to, or maybe more like 500 to 550, I would say. So Homo naledi does exist in its upper range outside of the range of the Australopithecines, but the crania is still rather basal, which if you look into some of the papers of the work of of the paleoanthropologists who did unearth Homo naledi, you'll find that they do remark about that the cranial capacity is very basal. But if you'll notice, if you'll go back to the pictures really fast, Dapper.
Absolutely.
Yeah, we've still got an incredibly orthognathic face. So like, look at the angle of, here, I'll show you on this skull. So this angle right here.
1 second. Now we can see him.
Yeah, so the orbit to the mandible, that angle right there, is relatively up and down in a human. So, hold on, like that. Is that? No, that's more forward. Hold on, I just got to get it so you guys can see it. Yeah, so you can see this is a relatively straight angle like that. Right? It's a little bit, we're not entirely orthognathic as a species, but we are much more flat-faced than other primates. So go back to Mrs. Please really fast, or Plus. Yeah, so you see there's this very extreme angle from the orbit to the ends of the teeth. Now go to our middleman, our Homo naledi.
Oh, where were we? There we are.
Yeah, so you see that angle is much more vertical.
Okay.
Our next skull, this is Littlefoot.
So there's this is from one of the skulls from Dmanisi, and we have Littlefoot here.
Yeah, so sagittal crest, brain case size. The brain case, when, like you said earlier, when taking into account the sagittal crest, the brain case is going to be much smaller. Now, you can't see the mandible on our Dmanisi specimen, but for the record, the mandible here on Littlefoot is fat. That you've got a very tall body and a very wide ramus that is definitively very, very basal among the apes. If you look at the ramus and the mandible on, for instance, a gorilla, it's very impressive. The brow ridge here is also much more sloped forward than it is on Dmanisi, which is much more like globular and forward. And if you'll notice, this specimen has no nose. It's got no bridge of the bony bridge of the nose that's present in Dmanisi is absent here. So brain case, brow ridge, mandible, nose, or I guess bridge of the nose.
Okay.
Those are all of the things that I find striking. Yeah. Oh, also notice the zygomatics as well. You've got this sharp V for Dmanisi, like this, and like that. Oh yeah, sorry. Yeah, so the skull here, when you look at the range, crap, I can't see the other side. There we go. So the range for the zygomatics, right, on the human skull, and then compare really fast again, Dapper, to our other hominins.
Got the Dmanisi skull, and then we've got this. Yeah. That one's that's an obtuse angle.
This one is much more close to a right angle, actually, I would say. It is obtuse, that's absolutely true. But you have to consider as well where it's connecting to the hinge of the mandible, and as well as how the brain case develops. So where it develops first is backwards, and then it gets taller, and then it hooks under as being more globular.
And this one, the zygomatics, they kind of arch dorsally, whereas in Littlefoot, they kind of have a slight like ventral deflection.
Well, and yeah, and the interesting thing is, go back to Demonice really fast, Dapper, will you? Yeah, so look at how it is in line with the orbits as well, and the brow ridge versus with Littlefoot, and then compare that here to our human skull. You know what? That's probably the way. That's in line with everything else, right?
Yeah, yep.
So the angle of where the orbits and the zygomatics are in relation to one another is like relatively flat, right? Yeah, in relation to our Littlefoot here, so our Australopithecine, the zygomatic is really fat in relation to the fatness of the brow ridge. But the angle, I would say, is actually much more similar with this Australopithecine to a modern human than the Damonice, which is almost angled upward and backwards.
Wait, Erica,
which is interesting.
Are you saying that this skull is itself mosaic?
Yeah, I would actually, yes, I would actually hazard that. I would propose that it's very, like, and the reason I was going back and forth is I was like, there's got to be some, I was like, I feel like this has got to be derived, right? Like in our Australopithecine, I was like trying to do my mental gymnastics and be like, all right, how do these relate to one another? But I think that looking at all three in relation to a human skull, Damonice looks more basal in the zygomatics. But keep in mind that in everything else, it's more it's more derived than our Australopithecine.
No, I think one important thing is that having a large number of individuals across closely related species that all show varying degrees of traits that we would consider derived and, more similar to, say, Homo sapiens, and more basal, which we might say, more similar to sort of the other great apes, because let's face it, humans are the most derived great ape by a big old margin.
Yes, in in relation to human evolution, yes. Although, keep in mind, if you look at the Y chromosome, the more derived member is actually going to be your chimpanzee.
Right. Well, I'm speaking simply in terms of gross morphology.
Yes, I would agree. I would agree.
But that's a prediction that evolution would make. It's like, okay, if humans share common ancestors with, say, genus Pan, and Pan is relatively basal in terms of gross morphology, which it is, we should see a whole host of organisms that are a little bit more morphologically similar to, say, genus Pan in some ways, and then more similar to Homo sapiens in other ways, and there should be this sort of patchwork of mosaic organisms. So I think still this is, and I say still, like this is, again, more of what we would expect to see if Homo sapiens and genus Pan share a common ancestor. And
well, this Littlefoot, this individual here, is already, like, if you pull up the chimp skull from the very beginning, Dapper, yes, and in relation to our, yeah, there you go. So already you see an explosion of, for lack of a better term, explosion of the brain case upward, even when not taking into account the sagittal, even when taking the sagittal crest into account, a sloping forward and kind of emergence of a forehead, like you see almost a vaulting upward, like a chimpanzee is extended backwards almost entirely, whereas our Littlefoot has an upward.
Yeah, on the chimpanzee, the tops of the orbit of the orbits are not that far from the top of the skull, whereas here there's a big old dome.
Yeah, you get a vaulting there. Also, Littlefoot is less prognathic than our chimpanzee is, and Biggie is. Look at the, you can't see because very well on the chimpanzee because it's kind of low resolution. Yeah, but what you would see too that's a biggie is the honking canines on the chimpanzee when compared to Littlefoot.
Yeah.
Littlefoot is going to be decidedly larger than a chimpanzee, but its canines are going to be maybe 2/3 the size of a chimp. Same thing with the, you're going to see heavier molars, more chisel-like incisors rather than incisors that meet almost like a pair of tweezers. They project outwards less.
I mean, if I'm being entirely honest, this is exactly what I would expect someone to want to see if asked what a transitional fossil between, say, a quote ape and a human.
You
would
know,
be.
the only thing that I would add is that I think that typically, if when people say they want a transitional, they expect all the traits to transition at the same time. So I think rather than a fully bipedal, small-brained ape, they would expect a semi-bipedal, big-brained ape.
Yeah, and that's no, I don't think that Kane is under the impression that that is what the story
I don't
is.
think I don't think Kane is either.
Yeah.
I'm just saying that when typically a lot of younger creationists don't
Right.
know the nature of transitionals and how different traits are sometimes independent of one another.
Yeah.
Yeah, I mean, overall, there's a reason why Australopithecus afarensis is pointed to as the missing link. Personally, I think habilis and sediba, Homo habilis and Australopithecus sediba are better candidates for your perfect transitional. But Australopithecus afarensis is fairly good as well, and Australopithecus africanus.
Okay. What do we want to talk about with this skull? For one thing, I
So,
noticed there's very little prognathis- prognatism. The
Flat face.
So if we could look at the one right before this, or not the
nullity. Okay.
but the
Oh, the one before
before
the Demonisi skull.
Yeah.
Okay.
So in between these two, personally, pretty much everything that fits the criteria of the human Homo erectus specimen back behind is suddenly apparent in this specimen, as far as brain size and full extent of prognathism and nasal projection.
So is this where you're saying that this is is this where you're identifying there being a gap here?
Somewhat, yeah.
Okay. Well, one thing I would say is didn't we have another skull from Demonisi on this list?
Yes.
Okay. Well, let's see. What was the other skull that we were looking at? It was this one. What about here? I mean, I will grant you that other Demonisi skull that we looked at, this one here, I would see a much bigger difference between this skull and this skull. But if we look at the other Demonisi skull, I see less of a difference, especially in the cranium. Or, sorry, not just the cranium, but sort of the brain case shape. So, I'm not sure that I see the same gap that you're seeing. But maybe Erica has...
So one thing that I wanted to say that I think is really interesting is that the gap that you're talking about is, in my opinion, it's an extension of traits that are already in existence. So, Dapper, if you'll flip very shortly through our Demonisi specimens.
Yeah, so we have this one, and there is this one.
Mm-hmm.
So these are the Demonisi specimens that we have.
I think didn't we also have a third?
Was this a Demonisi specimen?
Pretty sure
No.
that's Habilis.
Yeah, I don't think we did have a third.
Okay, we just have the two. So the really and truly the primary difference that I see between the Demonisi specimens, and the interesting thing is the thing that appears to separate the two Demonisi specimens that we have is the brow ridge. And I would say the zygomatics, but I think the zygomatics are just missing from this one here. I think that we just can't see them very well due to the resolution and maybe the integrity of the fossil itself.
Yeah, but it looks kind of like the posterior section of the zygomatic it might be missing.
That's kind of what I was thinking as well. I think though that other than the brow ridge and the bridge of the nose, to me it looks like go to the other one really fast, Dapper. Yeah, so the overall brain case size and shape seems pretty similar to me. It seems like it would fall. Other than that, you've got a little protuberance almost at the top there. But again, what we could be looking at is a slight difference in size and therefore an expression of the volume of the crania itself. But the interesting bit is when you compare this Demonisi specimen with our human Homo erectus, human style Homo erectus, Dapper, the one you just had up like 5
Oh,
seconds.
sorry. This one?
Yeah, that one. Other than the slight prognathism, or I would say moderate prognathism, and thus orthognathism in this species, and the protuberance at the nose, so your actual bridge of the nose appearing, the primary difference is just the size of the brain case, which would be continuing a trend that we saw in Dmanisi from the Australopithecines. So basically, you're seeing an expression of traits that were already existent being taken to a more terminal end, except with the sole exception of the bridge of the nose. So the bridge of the nose, you don't see a hint of. It appears. Well, actually, go to the other Dmanisi. So you can actually see a super, super slight nose bridge in this one compared to the other Dmanisi specimen.
Right here.
And to me, what that potentially indicates is that it's an integrity problem with the other one, especially considering we also have the loss of a posterior zygomatic in our other one. So what that says to me is we might actually have a slight nose bridge in both the Dmanisi specimens that's only present in this one. And that would actually confirm that every single trait that we see in this individual as being very basal is present in our more derived individual. It's just more derived. Yeah. So if nothing novel appears, it's essentially an exaggeration of existing traits, an exaggeration of a more orthognathic muzzle, an exaggeration of a brow ridge, an exaggeration of the cranial capacity itself. Does that track?
Yes.
Okay. Now, there's one thing that I want to point out, and it's not an entirely fair analogy, but I think it raises the question because for you, this skull that we're looking at here, this Dmanisi specimen, going to this Homo erectus specimen, you find that to be incredible in the technical sense. Like, it is not easily believed, as this organism could be ancestral, not necessarily directly, but in an ancestral lineage to this organism. But I know from our previous conversations that you accept that the domesticated dog shares common ancestry as a group. And we have significantly greater changes in the cranium of domesticated dogs than we can see between these two skulls.
But they're domesticated.
Well, great. But what I'm saying is we know that just genetic changes that can occur through mutation and selection, whether it be artificial or not, can more than account for this amount of skull shape change, right? Like, we know that's within physical possibility.
I would actually argue, Dapper, that in a more plausible, more applicable, more, what's the word I'm looking for? Reasonable from Kane's perspective would be to look at the difference between a cheetah and a lion, who, I would imagine from Kane's perspective, or even a cave lion and a modern lion, or a Dinofelis, which is an ancestral leopard and a modern leopard. All of those encompass differences and are decidedly, I would imagine, from Kane's perspective, correct me if I'm wrong, related and in an ancestor-descendant relationship in some cases, like from Dinofelis to modern leopards. And they also represent a greater change of exaggerated cranial characteristics than Dmanisi does from traditionally Homo erectus. Right. So Homo erectus from Homo erectus. I would argue, because neither of those are domesticated. The modern leopard is not a domesticated version of the ancestral leopard, Dinofelis. Dinofelis is just a more ancient version of the modern leopard. And does indeed occupy certain cranial characteristics that makes them different. You could also make the differentiation between Dinofelis and any of the modern African cats. For me, I would have to take Dapper's stance on this, not using the domestic dogs, and say there are many organisms that creationists, old Earth and young Earth alike, would accept as being related to one another that occupy a greater canyon of difference than Dmanisi and Homo erectus.
It does seem, and I'm not saying that this is an intentional thing, but it seems to me like a lot of the arguments where we get to saying that this alleged gap here in the fossil record, which one I would like to point out, you did again, I'm not accusing you of doing anything in bad faith, but the initial Dmanisi specimen that you wanted us to compare to this Homo erectus specimen was the one that was less like it. we had another Demonisi specimen from, it's a cave, right? It's Demonisi cave.
I don't know if it's a cave or not. Let me
I
check.
thought it was a cave. I might be wrong, but
Yeah,
from
not
that
looking at the
same,
block.
it's that same site, right? And so when you compare those, there's significantly less difference. And also, we have groups with larger amounts of gross morphological change over geological time, where, yeah, young and old Earth creationists will say, yeah, no, that's fine. But then we get to humans and we say, oh, that, I don't know, that cranial vault got a bit higher and that face got a little bit flatter. You see where that it feels like that's an odd sort of methodology? That you
I
wouldn't...
definitely do.
Okay.
I personally am working on different life forms, doing the same type of analysis.
Okay.
Because I do not subscribe to the same ideas that most other creationists would
I mean, that's fair.
promote.
You are absolutely under no obligation to do so. So yeah, it's...
So quickly, I want to make a note here.
Okay.
So this is important. So Homo georgicus, in the initial analysis, so all of the Dmanisi specimens, and I didn't know this in the past because I have not, this is a key thing, read through this entire book, like in recent years.
Can we see what book that is?
Yeah, Processes in Human Evolution. I'm still working my way through it.
Okay.
Because my whole human evolution textbook was Principles of Human Evolution. This is Processes. Homo georgicus, the site of Dmanisi, has been described in Chapter 3, where we stated the first hominin fossil found at the site was the mandible D211. Morphologic study of D211 by Leo Gabunia and Vecchia stated that this was a very old specimen of Homo without attribution to any species, which had small teeth and a large mandibular body, its gender uncertain. So essentially what they're saying is, and I, again, didn't know this, but when initially found, the Dmanisi specimens weren't said to even be Homo erectus. Also, in relation, because I know that some people think like, oh, sexual dimorphism, that's kind of a lame catch-all, but I didn't read this either, but it turns out they actually did a statistical study on the Dmanisi cranial samples and compared them to modern humans, chimps, and gorillas, and obtained results that supports the hypotheses of a single species. So they are essentially saying they fall within the range of all other hominoids with regard to the sexual dimorphism they would exhibit, even when including the cranial capacity. And that was a statistical study done by Sang He in 2005. And again, again in 2006 with the mandibular synthesis. So let's see. It says, if we accept only one species appears in Dmanisi, specifying which one is no easy task. D2700 shares affinities with specimens of Homo habilis, such as the one at Cubiphora, but Vecchia argued that although very small, the specimen from Dmanisi also has traits of Homo ergaster, which was, again, that other Homo erectus potential species that we have. So the systematic diagnosis acknowledged the difficulties of this classification, suggesting that the Dmanisi hominins would be among the most primitive individuals attributed to Homo erectus or to any other species, but without question belong to genus Homo. So essentially what they did to achieve that result, Kane, if maybe I wasn't clear earlier, but they ran a statistical analysis with the measurements of each of the aspects of the crania. And I think that was just done with the crania. I didn't see a mention of the postcrania in that. So they just looked at the crania and they were like, okay, capacity, angle of the foramen magnum, angle of the zygomatics, orbits, teeth, what do we get when we compare all of this? And it shares more similarities with genus Homo than it does with the Australopithecines when you run that statistical analysis. Now, and that was back in 2005. Again, I can send you, I don't think I actually have this paper in my research document, but Lee Sang-hee from 2005 is the one that did it. And then again, Collard in 2006, along with Skinner and Gordon. So maybe play this back, or I can just find it and send it to you later. But these guys essentially took your stance. They were like, okay, this is a really, really primitive looking organism. Is it even genus Homo? Is it possible that what we're looking at here is not a member of genus Homo? It's just so primitive. But the statistical analysis does confirm its position as super, super basal, but Homo nonetheless. I just thought that was kind of an interesting bit. I didn't know that. I don't know that. I'm not familiar with the Dmanisi specimen, so that's an interesting thing to note.
So it seems like far from being a place where we need to bridge a gap, the Demon-EC specimens overall, when you take all of the measurements into account, are actually sort of right smack where we might think there would be a gap.
I would even suggest that they're maybe even slightly before the gap, and then that gap is bridged further by other members of mid genus Homo, so Ergaster erectus, maybe even like Gautingensis, which is a more derived, maybe habilis lineage.
Okay. I have a question, Kane, for you.
Okay.
At this point, the skull that we're looking at here, not the Demon-EC skull. At this point, you were comfortable calling this human. Is that correct?
Yes.
Okay. But you were not comfortable calling this skull human.
Correct.
So I actually have a question. So under that, like with the knowledge that we currently just went over, and feel free. I mean, I'm not taking these guys' words as gospel. I would encourage you to go look at those papers and see what they say and see if you agree with them. I actually haven't read that one again, so I don't even know if I wholeheartedly agree with it. I would imagine that I probably would, just because these guys probably know the specimens better than I do. In fact, I know they do know them better, but whether their conclusions or not are viable to me as an individual, again, haven't read the paper, yet to be seen. But I would say tentatively that analysis is the crux of what you're looking at, what you as an individual are looking for here. Because what they did is, in an empirical sense, like not, because again, it's very easy to, and I've made this mistake before myself, it's very easy to eyeball something and place it and say, okay, this doesn't, this Demon-EC specimen doesn't look very human, this other Homo erectus specimen does, that's where I'm going to draw the line. But in my opinion, it seems problematic for you to hold that stance, because some individuals were like, we feel the same way, let's run an empirical study. And they did it with numbers, just sheer numbers and measurements. And they found that the one that you deem as being more basal groups more readily with the more derived members than the more basal members of the Australopithecines. So I think that would be, if you're wanting to make the case that Demon-EC specimen is more basal, it would be a great starting point to go to that 2005 paper and see why it is that they ended up grouping, statistically speaking, that specimen with Homo rather than the Australopithecines.
Yeah. And you are allowed to contest the findings of any given paper, right? But you have to be able to give your reasons. So, like, recently I contested, somewhat publicly, the findings of a paper in dinosaur paleontology, where there was a claim that a bird skull had been found in amber, and I said, looking at this, I do not think that we can be confident that this is even a dinosaur. Never mind that it's a bird skull. And I had reasons. Well, it's okay when they're that small. It actually can be a little tricky, but I had reasons to do with the skull morphology that I said this could just very well be a lizard. And it turns out that the authors retracted that paper, and after criticisms of people saying, how do we know this isn't just a lizard? What makes you think it's a bird? And so it's okay to...
That's awesome.
Yeah, you can do that, but when you are going to contest what a paper says, you need to give your reasons, and they need to be good reasons. You can't just be like, well, I don't like the statistical analysis. You have to say something like, okay, the statistical analysis is weak because if you include this in your data set, it changes the results this way, or this specimen was overlooked, or I have reason to think that this measurement was inaccurate for some reason. So if you can do those things, then great. Absolutely. Feel free to take those papers and say, no, these are trash, and here's why. But I find a lot of people end up saying, no, this paper is trash, and then because it disagrees with what my preferred conclusion. So be careful not to do that, because that's easy to do.
I agree. And like, I've been guilty too of looking at something and being like, that looks like it should be blah, 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 and then once the statistical analysis, comes out, I'm like, oh, well, shoot, that's hard to argue with, because I wasn't there taking the measurements. I didn't run the stats analysis. And being someone who has to run statistical analyses now for my thesis, they're hard to argue with, because essentially what statistics does, and this feels like something that is like common knowledge, but I didn't know it. Like, I was like, oh, statistics, it's probability. But it's not just probability; it's probability of relationships, and it's probability of relationships with other relationships. And it's something that if you're going to contest, like Dapper said, the best bet would be like, okay, well, not that the statistical analysis is wrong, but that the variables are wrong.
Right.
Right. Well, like that would be your best bet.
So what I would recommend then is if you wanted to do something like contest that study, and this is actually just for anyone who ever wants to contest a study, right? So this is particularly a paleontological study, right? So what that means is that you can find the descriptions of these specimens somewhere else that's been published. Otherwise, people wouldn't be running this current statistical analysis on them because you couldn't get the data from anywhere. So you could actually look at the original descriptions of these specimens and try a new statistical analysis with the metrics that you think are relevant and explain why you think they're relevant, and then run and say, okay, so this is why I think these measurements I'm using in my analysis work better, and hey, look, it confirms or disconfirms my hypothesis that, say, the Dmanisi specimens are actually not humans, they're just Australopithecines, they have no particular connection, there's a big gap there, and maybe that'll happen, but you also have to be ready to defend your choices because other people will come back with other data sets, including those two papers, and say, well, why is this not valid? So it's tricky, and you could possibly actually have something there, and quite frankly, if you do it rigorously enough, you could possibly even submit it, although don't hold your breath because it's very hard to get papers approved. But the thing is, there's technically anybody can submit something to be published. You don't have to have any degrees in particular, you don't have to have any particular credentials. All that matters is that you did your work right and you followed the submission guidelines. Also, it helps if you don't fraudulently add the watermark of the publication before it's published.
Yeah, you'd basically publish it as a comments. You'd be like, comments on, 2005 on Dmanisi. That's
there it is.
Dmanisi, comments on Dmanisi cladistic analysis or something like that. And you'd be like, I think that, perhaps the measurement of blah, blah, blah wasn't good, or maybe the inclusion of this should be considered, or whatever. I mean, Dapper's right. Like you could literally do this if you wanted to.
Yeah.
It's a lot of work for it. It really does just depend how much it means to you and how rigorous you feel about proving that that Dmanisi specimen is an Australopithecine.
Right.
So it depends on how strongly you feel about that. And my friendly advice as someone who's trying to write a thesis right now would be, which typically tends to be published as a paper at the end, is to do like a super heavy lit search on it. Like any paper that's out there on the Dmanisi specimens, like just read it and like take really good notes. Plug that data into an Excel file, and my gut feeling is that you'll be like, this is pretty rigorous, because usually, especially post 2000, they tend to be pretty good about like making that information publicly accessible, so that you can kind of look at it yourself. But anyways, like, yeah, I think you should do it. I think it would be super interesting because
I would be very interested.
Yeah, those specimens are really weird. Like, I agree with you. I think, I guess I'm coming at it from more of an angle of they're weird in a way that is like, why is this species so sexually dimorphic when Erectus isn't typically, or Erectus style organisms aren't typically that dimorphic?
See, it always comes back to the sexual dimorphism with Erica.
It's always sexual, but again, that's what I'm studying too.
Right.
So like, that's on the forefront of my mind is like, oh, are we taking into account the difference between males and females? Because as it turns out, males and females can indeed be very different depending on the species, and they don't even have to be. Yeah. Thanks, Papio. Thanks, Mandrillus is really what you should be looking at. I mean, Mandrillus is absolutely insane. The males are like 4 times the size of the females. Their canines are like daggers.
I just realized I don't think we've given anyone the common name for genus Papio or Mandrillus, but that's fairly easy. That's mandrills, but
yeah, baboons, and for mandrill, it's mandrills and drills.
Yeah.
So Mandrillus leucophaeus and Sphinx.
Sorry about that for everyone who isn't up on the binomials for all these animals.
Macaques too are bad about it. Macaques are also pretty dimorphic. And then you get like Gwynins and Colibans, and it's like you can't tell the difference between the males and the females size-wise, and then they open their mouths, and you're like, oh, that one's a male, and it's got these big honking canines, except with Presbytus and Colobus scoriza, where the females just have big-ass canines, and no one knows why. Like, why did this happen? They're right next to all of these dimorphic Colibans. What's going on? And that's what I'm trying to figure out.
Nice.
So...
All right, let's flip back to these skulls. I want to take a look at this next one here. So at this point, we're saying that all of these further skulls that I'm clicking through are in fact human.
Right. In fact, evidence of evolution.
Okay, so here's one.
If you look at it.
Here's one thing I would say. So this skull here. Actually, let's just Okay, so. This skull we're agreeing is human, and this is I believe is a Homo sapiens skull.
No, yes. Look how globular the bottom is too.
I was looking. I was like, "There's no occipital bun. It's very globular." I'm gonna go ahead and tentatively say Homo sapiens, even though I'm far from an expert. But so I don't see the difference between this skull and this skull as being so much greater than the difference between this skull and say. This skull, honestly.
Right.
For me, it's brain case. Like that's going to be your big difference between the two of them, and that's my point. Would be it's an exaggeration of a trend that's already happening.
Yeah.
Which to me, it's like okay, if you're going to be like, here's the line, here's what evolution can do, and here's what evolution can't do. It would be like the difference between growing gills, right? Or I guess that's a bad example. Growing digits, let's say. Developing digits in a species versus making the skull bigger. Like making the skull bigger seems, I would imagine most creationists would be like, okay, yeah, that's an exaggeration of an existing trait. It's not that difficult. But going from a fin to a hand would seem like a larger step, something that you would contest more readily. So at that point, I would be like, where's the stopgap here, right? Like, where is the problem? Because growing a bigger skull isn't that hard. We do it ourselves in 9 months, right? Like it's not that difficult. But developing a unique novel structure is. So that would be my question. It's like, what's the novel structure in human evolution? Where do we see the impossibility? And usually people tend to say, for me, that's behavioral. And then I'm like, okay, but then it's not evolution.
Right.
Right.
If you could find, say, like a particular organ or bone or something, some anatomical feature, and then say, this brand new thing, and it's not anywhere in any of the other apes, I would say, well, that's an interesting point. Like, if it turns out that, like, I don't know, none of the apes had a fifth digit, but humans do. Like, well, that's unusual because, digit loss over time is a thing, but you don't normally go up in digit count from your starting point. It's very rare. There are polydactyl organisms, but that's usually a more of a genetic problem than a feature.
Well, and even then, Dapper, I don't even think you could say that because we have so spider monkeys, so like your Ligothrix and your Brachyteles and those individuals, and some of our Colibans, they lack thumbs. They have heavily reduced thumbs, and so they're swinging around on their four digits. And so I don't think anybody would look at that and say, oh, it's no longer a monkey because it lacks a thumb.
But what I mean is, like, if humans had an additional organ or structure that was nowhere else in primates.
Right, yes.
Then I would say that would be curious, and that would demand an explanation that I don't think is currently forthcoming from, say, evolutionary biology, but we don't have such a structure. And that would be one of those easy ways that you could pretty easily overturn a lot of our current thinking, is you could say, okay, well, humans have this thing. Where is it on a chimpanzee? It's not there. Why? But the problem for creation is there is no such part of morphology. Sorry, go ahead.
Yeah, it just always boils down to what we're doing. And like, again, like, I can't stress this enough. I'm cool with that. Like, if you want to be like, humans are doing different things. Yes, we do some things that are very different. But evolution doesn't really care about behavior as much, like only in the sense that it yields morphologic change.
Right. Like the reason that that Serenians and elephants are different is because they're nearly identical, very closely related ancestors. One of them ended up eating more grass and bushes, and one of them wanted to chop down on, like, seaweed. That's
Creationists would be in such good luck if they had just waited like 500,000 years until we humans had lost our wisdom teeth.
And then the dental formula would be different?
Yeah, because then they could just be like, the dental formula is totally unique. You can't prove that you can lose those teeth, And then you would be like, well, and because here we are, and we're like, I had all 4, but
Right.
For instance, one of my good friends had 2. And it's like, okay, well, why'd she have 2 and I have 4? It's because I'm less evolved.
Yep. And to lift up the mask a little bit, I have all 4, and they all work. I have a very basal jaw in that sense, whereas I have functioning, perfectly formed, non-impacted wisdom teeth. But yeah, so it's one of those things where, like, you don't have to even look at the fossil record to find transitions. Homo sapiens is currently in a transitional state between two different morphologies, with wisdom teeth and without, which means it's a species with a variable dental formula, which is unusual in mammals.
And that's kind of huge too, because the interesting thing about that is, like, the primate dental formula of the catarrhines just hasn't changed in, like, literally 20 million years. Like, we've always had 2, 1, 2, 3, and all of a sudden, in this moment in time, we're going to be switching to 2, 1, 2, 2, which is insane. It's very cool.
Yep. And we're also now at the point where we have people with different numbers of teeth on the top and bottom. So even within the person, you have to make sure you differentiate between the top formula and the bottom, which is not normally the case.
Alien paleontologists are not going to be happy with this area of human. They're going to be like, "Are you serious? How do we classify them? They've got this different dental formula, but only sometimes."
Right. So that's one of the things I find really interesting about this whole thing is this is not something that just happened in the past. We're watching it happen right now with actual humans. Humans are currently evolving before our eyes. Now, advances in medical techniques have probably relieved a lot of the selection pressure.
I would bet we would still, if we would all be wisdom teeth bound if it weren't for modern medicine. Like, we would all still have our 4 wisdom. I think you're right, Dabra. I think it's a lot of it is wisdom teeth can get impacted and infected and kill people. And so there is just a selection for, like, well, okay, I guess we'll just go, or there isn't a selection to keep all the wisdom teeth because we're not chowing down on hard foods and tubers. It's like Africans, like Central Africans, have the best teeth in the world. I'm not kidding. Their teeth are all straight. They fit everything in the jaw. Their jaws are impeccable. My old human evolution professor is a tooth specialist, and he was like, you don't find people with better teeth than the Hadzabe tribe. Like, their teeth are perfect.
Hey, good job, guys.
Yeah, and also it's because they eat hard foods as youngsters, so it naturally accentuates the muscles of the jaw, and, like, there's some plasticity there, so the jaw is more robust as they grow. That's what he said. Anyways, it was very, very interesting stuff.
Which actually is something that I want to say about the some of the skulls and things. Is one thing that you do have to take into account is differences in life history as a child can result in different overall morphology as an adult. Like, the growth of your bones is not completely predetermined genetically. There are things that you can do that will cause bones to grow less or grow more, or things like that. Like, for instance, the general trend over the last couple hundred years of humans getting taller has not primarily been genetic, because we have genetics from people from a couple hundred years ago and much farther back than that. It's mostly because humans have more ready access to high quality calories, and so
we are big boys because we eat a lot.
Basically, yeah. I mean, it's true. If you want to grow up to be strong, you have to eat your fruits and vegetables.
Unfortunately for many of our for some of our vegan friends, if you want to grow big and strong, you got to have a lot of that B12. So either you got to supplement your child or you got to give your kid meat.
Yeah.
And so that's rough for our vegan friends, but I'm not saying
without modern technology, veganism would not be a viable option.
Yeah, no, I that's the thing. Like, I think veganism from a perspective of, like, factory farming and climate change is horrible is a proper response. But at the same time, like, you're not going to convince any anthropologist or any primatologist for that matter that meat isn't a natural part of. And I'm not saying natural is better. It's not. I'm just saying, morphologically speaking, we are evolved and adapted for meat consumption.
And specifically for cooked food too. That's
Yeah.
because there's also the raw vegan thing. It's like, no, humans evolved for quite a while cooking their food, and we have evolved to eat cooked food. Our teeth are ill-suited for chewing on raw tubers and leaves, and
we could probably figure it out. Like if there was an apocalypse tomorrow and for whatever reason we couldn't manage to start a fire, like you'd probably be able to survive on it, but you would not be we'd probably see a massive decrease in general body size really fast, like in a couple generations.
Yeah, and that might even include some genetic changes because less access to calorie favors smaller body size because you don't have to eat as much. But anyway, that's super off topic.
Holla at me, Island Dwarfism.
Oh yeah, you just had a video about that. So
love it. Love Island Dwarfism and Island Gigantism. So, I'm so sorry, Kane. We literally are so off.
Yeah, we went very, very far off topic.
I'm so sorry.
Now I stopped the screen share of the skulls because I don't think we need to go into excruciating detail on every one of the skulls that you accept as human, because the contention that we have is whether or not there is common ancestry between the ones that you're not considering humans and the ones that you are. We all three of us would agree that the ones that you are counting as humans all share ancestry, and they're all within a range of morphology that can be easily explained by standard evolutionary processes, right?
Right.
So yeah, I don't think we need to then, in that case, examine all of them.
One thing, I don't think it was in that particular file, but in one of them, I did do the Florenziensis. Is that correct?
Yes,
nice.
Yes.
And it fell quite on the human end of the spectrum.
Interesting.
Well, Floresiensis is, again, the cladistic analysis, contrary to what Standing says, it's been known for at least since 2009 via cladistic analysis that Homo floresiensis is probably a branch off of habilis or rhodolfensis. Like it's pretty basal. Small brain, weirdly basal arms. Like this dude was probably climbing around quite a bit. It's a weird deal. Sorry, flies trying to get my triops.
I think we've pretty much covered what we have. We have what we're going to talk about. So we have some recommendations for Kane, what you could do if you want to continue this this research that you're doing, including up to the point of even entering into the discussion at a professional level. Like you could actually do that. It would, again, be a lot of heavy lifting. But we can send papers, especially Erica can send papers because she's much more familiar with that literature than I am.
I've got it at my fingertips. Seriously,
right.
It's absolutely no problem. Do you want that, Kane? Do you want me to send you some good papers in this? Okay, yeah. I can send those to you probably by the end of the evening.
Okay. So I think here's a pretty good spot to wrap it up. In terms of recording time, we've been going for just under 4 hours. I've had fun, and I just want to say thank you very much, Kane. This has been a much more enjoyable discussion than, say, the one I had with maybe Mr. Batman.
Oh my god.
So
yeah, I hope that I don't know. I hope that even if you disagree, like I hope you enjoyed the conversation as well. And I'm so sorry we monologued for so much of it.
Yeah, I really enjoyed it.
Thanks for watching, but before you go, I'd like to take a minute to say thank you to my patrons and channel members on YouTube. They help me make this channel possible, and without them, I couldn't keep going. Specifically, I want to thank my $20 and above patrons, Bent Hovend, Ian Chen, Sphincter of Doom, Chris Love, Henry Hutanen, and Bob Knob. If you'd like to join the channel or become a patron, links are in the description, and if that's not right for you, but you want some other way to help out, there's also an Amazon wishlist, as well as a Teespring store where you can get Dapper Dino merchandise. If none of that works for you, just liking and sharing this video really helps out. I'm the Dapper Dinosaur.
So you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.